Welcome to the Sleepy Science Facts. I invite you to find a comfortable position, allowing your body to relax as we drift into a gentle exploration of the world around us. If you find yourself enjoying these calm pieces of information, feel free to like and subscribe, creating a space for more peaceful moments like this. Today, we can reflect on a curious aspect of our world. What happens to the colors of fire when it burns different materials? It is fascinating how the colors of flames can change based on what is placed within them. When different materials are set alight, they respond in unique ways. This is due to the specific chemical elements present within the materials themselves. As these materials burn, they release energy, causing electrons within their atoms to become excited. When these electrons return to their original state, they emit light at various wavelengths. This light is what gives flames their color. For example, if copper is introduced to the flame, it often produces a calming green hue. On the other hand, sodium results in a bright, cheerful yellow. What is gentle to consider is that this behavior remains steady over time. The elemental makeup of these materials does not alter during combustion, allowing the same colors to appear consistently when those materials are observed burning under similar conditions. Each element has its own signature, reflected in the vibrant display of light when it interacts with heat. As we contemplate the simplicity of this phenomenon, we can appreciate that the world of fire is an intricate dance of light and energy. Each flame is a reminder of the elements that make up our surroundings and their unique properties. With this understanding, we can continue to explore the depths of this captivating topic. In certain situations, fires can create a phenomenon known as a fireball. This happens when a substantial amount of burning gas gathers and forms a spherical shape, often resulting from explosions or particular conditions during combustion. The process unfolds when a large volume of flammable gas mixes with air, igniting and releasing energy rapidly. As the gas burns, it creates a hot, expanding mass that pushes against the cooler air surrounding it. This results in a visible ball of fire, often glowing and pulsating gently as it rises or moves through the air. This shape is temporary and ephemeral, existing only for a brief moment as the energy dissipates. The conditions required for this fireball to form depend on various factors, such as the concentration of fuel in the air and the available oxygen. As these elements blend together, the result is a striking visual display of heat and light, reflecting the dynamic interplay of combustion. Contemplating this, one can appreciate how even in the natural world, there exists a rhythm and sequence to these energetic phenomena. The dance of elements in such moments reflects the inherent qualities of matter and energy, inviting us to delve deeper into the quiet mysteries of the universe. For fire to thrive, it relies on a delicate balance of three essential components: fuel, oxygen, and heat. Fuel can take various forms, such as wood, paper, or other combustible materials, providing the foundational substance that burns. The presence of oxygen is crucial, as it acts as the supporter of combustion, allowing the chemical reactions to take place. Heat serves as the activator, elevating the temperature to a point where the reaction can occur. When these three elements are combined in appropriate amounts, a fire can sustain itself. The interaction is continuous, requiring that each element remains available and in harmony for the fire to persist over time. If any one of these components is diminished or removed, the fire will struggle. A fire in a controlled environment will maintain this equilibrium, creating a gentle glow and warmth. The intricate dance of burning fuel, swirling oxygen, and the steady heat reflects the fundamental nature of energy transfer. Observing this process allows for a deeper appreciation of the vast interconnections in the world around us, where even the simplest reactions can produce profound effects. The gentle crackle and flicker of a flame serve as a reminder of the ongoing cycles of energy and matter, quietly unfolding in the background of our existence. Fire pitting occurs when surfaces experience prolonged exposure to intense heat and flames, leading to a gradual erosion that creates small indents or craters. This phenomenon is notably observed in locations where high temperatures are frequently present, such as the scorched earth surrounding wildfires. As flames flicker and dance, the intense heat can wear away materials, altering their structural integrity. The surfaces affected may begin to show tiny depressions, reflecting a slow but steady transformation driven by the relentless nature of fire. Each moment that they are exposed to heat allows the flames to work their way into the materials, softening them and allowing for this unique erosion to take place. The patterns of fire pitting are varied, depending on the material and the intensity of the heat. Over time, these small craters accumulate, creating an intricate texture that speaks to the history of intense energy exchanges in that space. This ongoing process reveals the subtle yet powerful changes that can occur when solid surfaces are subjected to the element of fire, a testament to the transformative power inherent in natural forces. There is a quiet beauty in observing how even the earth itself yields to such energy, embodying cycles of destruction and renewal in a gentle, ongoing rhythm. Blue flames emerge as a rare and striking phenomenon when natural gas undergoes complete combustion, producing a specific color that is distinctive from the familiar yellow flame. This blue hue indicates that the gas is burning efficiently, signifying an optimal mix of fuel and oxygen. Here, the combustion process is nearly flawless, resulting in minimal soot production and significantly less waste. The blue color arises from the specific wavelengths of light emitted during this efficient burning. When the carbon in the gas is fully oxidized, it produces carbon dioxide and water vapor byproducts that are clean and less harmful. Observing these blue flames can inspire a sense of calm as they reflect the balance of elements coming together harmoniously. This efficient combustion can be influenced by various conditions, such as the temperature and the exact concentration of gas and oxygen present at the moment of ignition. As the flame flickers gently, it indicates a system operating at its best, quietly illuminating the surroundings with a serene glow. Such moments bring a deep connection to the simpler, yet intricate processes of nature, inviting a peaceful acknowledgement of the interplay occurring within fire itself. In ecosystems where fires are a regular occurrence, some plants adapt over time by developing thick bark. This thickened layer serves as a protective barrier, insulating the vital tissues underneath from the heat and flames that sweep through their environment. The formation of this bark is a gradual process, as plants respond to the cyclical nature of fire within their habitats. Thick bark can vary in texture and density, depending on the species and the specific conditions of the ecosystem. As these plants grow, their bark becomes more resilient, helping to shield them from the damage that a fire might bring. Each season, with the rhythms of nature, influences the bark's development, creating a sturdy exterior that can withstand periodic blazes. This adaptation not only allows the plants to survive, but also plays a role in the broader ecosystem. The resilience afforded by their thick bark enables them to thrive in environments where fire can rejuvenate the landscape, promoting the growth of new life in the aftermath. In this way, the dense bark stands as a testament to the enduring balance within these fire-prone habitats, inviting calm reflection on the natural processes that shape and sustain life. The combustion process in a fire creates a range of gases, with carbon monoxide being one of the notable byproducts. This colorless, odorless gas forms as organic materials burn and can present significant health risks when inhaled. As a fire burns, the concentration of gases fluctuates, influenced by the availability of oxygen and the arrangement of materials. In spaces where ventilation is poor, these gases can accumulate, leading to increasing levels that may linger even after the flames have extinguished. In the quiet aftermath of a fire, the air can still carry remnants of this chemical reaction. The dynamics of the environment play a crucial role in how these concentrations change, subtly shifting based on temperature, humidity, and airflow. Oxygen levels, in particular, determine how effectively the fire can consume available materials, which in turn influences the composition and quantity of gases released. Even when the visible signs of the fire have disappeared, the lingering presence of these gases introduces a complex layer to the landscape. It becomes a reminder of the invisible interplay of elements occurring all around. As the setting returns to calm, the dance of particles within the air exists silently, awaiting the next change in conditions. The minimum size for a sustained fire, referred to as the threshold size, rests around 10 grams of combustible material. This threshold can vary depending on the characteristics of the material itself. Different substances behave uniquely when exposed to heat. The structure of their molecules plays a role in how easily they ignite and how long they can sustain a flame. In the quiet moments of combustion, those molecules begin to break apart, releasing energy and forming new compounds. This process is delicate, relying on the right conditions to maintain a steady burn. As the fire consumes the material, the flames flicker gently, drawing in oxygen and transforming the solid into heat and light, like a slow, rhythmic pulse. If the amount of combustible material is below that threshold, the fire may struggle to maintain itself. The interplay of heat, oxygen, and fuel must be balanced for a flame to endure. In a serene space where these elements align harmoniously, the fire can thrive, quietly continuing until it meets the limits of its supply. The journey of combustion exists as a gentle dance, each element contributing to the whole, resting in a calm state of balance and readiness. In certain ecosystems, fire plays a quiet yet important role in the cycle of life, occurring naturally every 5 to 100 years. This occurrence is part of a process known as natural succession, where the landscape gradually transforms over time. The intervals between these fires allow the land to adapt and evolve. Fire-adapted species have developed unique characteristics that enable them to thrive in the aftermath of a blaze. Some plants have seeds that require the heat of fire to germinate, while others have strong roots that survive beneath the surface, waiting for the right moment to sprout again. This relationship creates a dynamic environment where new growth emerges alongside older generations, contributing to a rich tapestry of biodiversity. As the flames sweep through these habitats, they create openings that allow sunlight to reach the forest floor, stimulating the growth of various plant life. Small creatures that thrive in the underbrush find new homes, and the cycle renews itself. Each fire sets the stage for the next chapter of life, a gentle rhythm in the ongoing story of the ecosystem. Such processes quietly foster a balance where life flourishes in a delicate weave of interdependence and renewal, inviting a sense of calm and continuity in the natural world. In some instances, wildfires can intensify to a level where they begin to generate their own weather systems. This fascinating phenomena occurs as heat from the flames rises rapidly, causing a dramatic shift in air pressure. The surrounding air is drawn in to fill the space left by the rising heat. As this process continues, it creates small swirling columns of air known as fire whirlwinds. These vortices can be both mesmerizing and intense, with temperatures reaching astonishing heights of over 1,500 degrees Celsius or 2,732 degrees Fahrenheit. Within these whirlwinds, the combination of heat and movement creates an environment unlike any other. The winds can carry embers and sparks high into the sky, potentially igniting new fires in distant areas. This natural occurrence exemplifies the complexity of fire's influence on its surroundings. As the swirling heat interacts with cooler air above, it leads to shifts in temperature and pressure that ripple through the atmosphere. Even in this extreme state, the cycle of energy continues, connecting the ground below to the air above. It reflects the raw power of natural processes unfolding in harmony. The landscape remains in a gentle dance of destruction and renewal, with the rhythm of fire ultimately shaping the ecosystems around it in ways that are profound and lasting. Such transformations linger quietly in the backdrop of nature's continuous flow, inviting further exploration into the intricate systems at play. In Mediterranean climates, the seasons bring a steady rhythm to the environment, shaping the landscape in unique ways. Each summer, as the days grow warmer and drier, conditions become ripe for wildfires. This annual cycle is influenced by a combination of low humidity, elevated temperatures, and the availability of dry vegetation. These factors align to create a predictable pattern where the potential for fire rises each year. Vegetation that flourishes during the wetter spring months becomes dry and brittle under the summer sun. The rich biodiversity, typical of these regions, often includes various shrubs and trees that, while resilient, also become fire-prone as the season progresses. As the heat intensifies, the natural oils and resins in these plants may evaporate, increasing their flammability. This change in the landscape signals the onset of wildfires, which often erupt with little warning. The dance of nature unfolds as flames consume the dry underbrush, releasing energy back into the ecosystem. In the aftermath, these fires can enrich the soil and promote new growth, continuing the cycle of life. This process is an intrinsic part of the seasonal rhythm in Mediterranean regions, allowing for both destruction and renewal, and reminding us of the ever-present balance in nature's design. As the seasons turn, the pattern continues, echoing through the landscapes shaped by sun, fire, and the slow, gentle passage of time. The gentle flicker of flames releases various particles into the air, including ions, which carry an electric charge. This process occurs as the intense heat of a fire causes molecular changes, leading to the ionization of air. As these ions are emitted, they interact with surrounding air molecules, creating an atmosphere filled with charged particles. This ionized air is a unique state of matter, subtly altering the air quality in the vicinity of the fire. After the flames have died down, remnants of this ionization can still be felt, lingering softly in the environment. The charged particles hang in the air, slowly drifting apart as the minutes and hours pass. This gradual dissipation is a natural process, where the vibrant energy of the fire begins to fade. The air may feel a bit different, carrying an ephemeral quality that is linked to the recent presence of flames. Over time, the atmosphere returns to its neutral state as the ions lose their charge and mingle with the surrounding air. This slow transition reflects the delicate balance of energy and matter, a quiet reminder of the fire's once vibrant pulse. As the night deepens, The evanescent traces of ionization fade into the stillness, leaving behind a sense of calm in the air. In the midst of a fire's dance, a remarkable phenomenon can arise, where flames spiral into a graceful vortex. This occurs when heat generates enough energy to create a strong upward draft, pulling surrounding air upwards and creating a dynamic movement that resembles a tornado made of fire. Within this spinning column, the flames twist and turn, forming an elegant structure that captivates the eye. As the vortex builds, it can reach temperatures soaring beyond 1,000 degrees Fahrenheit, radiating a fierce heat that is both mesmerizing and powerful. The swirling motion pulls in air, intensifying the combustion and sustaining the fire's energy. The interplay of heat and airflow creates a unique environment where the flames dance in a circular rhythm, constantly drawing in fresh oxygen to keep the phenomenon alive. These fire tornadoes can travel considerable distances, carried gently by the winds that guide them across the landscape. They are fleeting, yet while they exist, they embody the incredible forces of nature at work. The warmth from such a vortex can be felt from afar, even as the swirling flames continue their journey. This cycle, though temporary, unfolds quietly in the vastness of the natural world, drawing together elements in a harmonious motion before eventually fading away into the stillness. When materials ignite, a transformation begins, leading to the creation of fire. This process releases energy in the form of heat and light, resulting in the formation of hot gases that fill the space around the flames. Among these gases, carbon dioxide, water vapor, and nitrogen emerge as the prominent components. As materials burn, the internal structure of their molecules changes, bonds break, and new ones form, resulting in a release of energy that fuels the fire further. The hot gases rise and expand, creating a volume of warm air that gently disperses into the surrounding atmosphere. This rising column behaves in a dynamic manner, driven by the heat generated within the fire, moving with a rhythm that reflects the energy released. The presence of carbon dioxide, a byproduct of combustion, adds to the complexity of the atmosphere surrounding the flames. Water vapor, another essential element, forms as the material transforms, often visible as a mist or haze above the fire. Together with nitrogen, these gases interact, contributing to the unique conditions within and around a fire. This delicate balance of hot gases continues to evolve, exhibiting a tranquility that aligns with the gentle flow of the forces at play, creating a peaceful yet vibrant display that unfolds softly. The fire produces warmth, which influences the air around it in a gentle and soothing manner. As the flames flicker and dance, they heat the air, causing it to rise. This upward movement creates differences in pressure between the area near the fire and the cooler air surrounding it. Such differences stir the air into motion, generating soft convection currents that drift quietly along their path. These currents lead to the formation of drafts that flow smoothly, carrying warmth and gases away from the site of the fire. Even as the fire consumes its fuel and shifts in intensity, the drafts tend to maintain a level of stability. The heat radiates outward, creating a continuous exchange between the warm air and its cooler surroundings. The gentle movement of these currents fosters an atmosphere full of subtle changes, contributing to the overall environment around the fire. This pulsating cycle of warm and cool air carries with it the essence of the fire's presence, weaving through the space in a soft whisper. The ongoing interaction quietly connects the fire with the world around it, allowing the cycles of air to flow, breathe, and exist in their tranquil state. The gentle heat of fire affects the soil in profound ways, creating subtle changes that extend far beyond its flickering presence. As a fire burns, it releases various nutrients and minerals stored within organic matter. These elements, such as phosphorus and potassium, are set free, enriching the soil with vital components that support life. Once the flames have ceased, the remnants of the fire continue their work. The ash left behind serves as a soft blanket, slowly breaking down over time and blending into the earth. This process introduces an array of nutrients that can stimulate growth for plants, creating a fertile environment. In the years that follow, these rich amendments can influence the types of vegetation that thrive in the area. The altered soil composition can lead to diverse growth patterns, fostering a mixture of old plants and new sprouts. This interplay between the remnants of fire and the soil lays the groundwork for a delicate balance, inviting life to return in rhythmic cycles. Throughout the seasons, the earth breathes and remembers, nurturing the seeds of tomorrow beneath its surface, leaving the environment open and ready to embrace its ongoing transformation. The remnants of a fire, particularly the hot embers that remain, hold on to their warmth for quite some time. Deep within the glowing coals, energy continues to radiate. This gentle release of heat can linger long after the bright flames have faded into quiet darkness. The embers are not merely remnants. They possess a structure that allows them to retain heat effectively. They are often surrounded by a mix of ash and unburned material, which can provide insulation, helping to trap heat within their core. The warmth slowly seeps into the surrounding environment, transferring energy to nearby objects. This slow release creates a comforting warmth in the area, influencing its temperature gently and significantly. Materials such as soil or wood can absorb this heat, maintaining a pleasant warmth for hours. Even as the evening deepens and the world settles into cooler temperatures, the embers carry on, softly enriching the surroundings with their fading light. Time unfolds quietly while the echoes of warmth continue to cradle the earth, creating a peaceful atmosphere where life may once again awaken softly in its own rhythm. Smoke, a delicate mixture of tiny particles and gases, is influenced by gravity in a gentle yet profound manner. When something burns, it releases smoke, which begins its journey upward. Gravity acts on this rising plume, gently pulling down the heavier particles while allowing the lighter gases to ascend higher into the air. As the smoke rises, it begins to disperse, spreading outward in soft, curling tendrils. The ambient air, warmed by this rising smoke, creates a current that encourages its upward path. This interplay between gravity and the air currents shapes the movement of smoke, dictating its form and reach. With each gentle swirl, the smoke blends into the surrounding atmosphere, gradually altering its clarity and quality. The particles carried into the air can linger momentarily, suspended delicately, until they settle back down or continue to disperse. This gradual softening and blending can affect visibility, making distant objects appear slightly hazy. Within this continuous dance of particles and air, the very nature of smoke unfolds slowly, capturing the essence of movement in the most peaceful manner. A quiet observation of this phenomenon invites a sense of calm and connection to the natural world. A fire, a captivating phenomenon, relies on a fuel source that provides it with the energy necessary to sustain its glow. This fuel can take many forms, whether it be wood, paper, or other materials rich in carbon. As the fire consumes these materials, it undergoes a process known as combustion, where chemical reactions occur, releasing heat and light. with every flicker and crackle, the fire transforms the fuel into ash and gases, showing an elegant cycle of change. However, as the fuel is gradually depleted, the fire's intensity begins to wane. The once vigorous flames might dwindle into gentle embers, as the remaining material no longer supplies enough energy for combustion to continue. This limitation of fire is straightforward, marking the end of its bright, lively dance. The gentle smoldering may remain for a while, but with time, even the last embers will fade, leaving only a quiet reminder of the warmth that once was. In this way, fire, in its transient beauty, demonstrates the essential nature of limits, resonating with the calm rhythms of existence around us. In natural environments, certain types of fire play a role that fosters balance within ecosystems. These wildland fires, gentle yet powerful, may seem destructive at first glance. However, they can create a stable state over time, promoting growth and enhancing the diversity of life around them. The heat from a fire can clear away dense underbrush, allowing sunlight to gently touch the soil. As these areas are renewed, new plant species take root, leading to a flourishing of greenery that provides nourishment for various creatures. Over the years, this cycle encourages the growth of trees and shrubs, creating habitats where animals find shelter and food. The flames, in their transient and vigorous form, contribute to a larger process of renewal, allowing the ecosystem to reset and thrive. Within this balance, the relationship between fire, growth, and habitat becomes a serene dance, encapsulating the essence of life's continuous cycle. This harmonious interplay nurtures the land, promoting resilience and variety, ready to unfold and grow anew. Fires, while they embrace the land with their heat, also bring about subtle changes in the hydrology of an area. After the flames have left their mark, the soil often undergoes a transformation that affects how water moves through the landscape. With the layer of vegetation removed, the ground can become less permeable, making it more difficult for water to be absorbed. This change can lead to noticeable shifts in local water flow patterns. Rainfall may pool in areas where it once soaked deeply into the earth, changing the pathways that water follows. Over time, new patterns establish themselves, shaping the landscape in unforeseen ways. As the soil adapts, it begins the slow process of recovery. Natural forces work together, encouraging new plant life to spread its roots once again, which can gradually improve water absorption and restore balance to the environment. The relationship between fire and water dynamics unfolds slowly, almost quietly, as years pass. Each cycle brings new life and changes as the ecosystem learns to adapt and flow gently into its next stage of existence. The color of a fire reveals a quiet story about the temperature and materials inside. As the flames dance, they emit hues that can range from soft yellow to deep blue, each shade drawing from the elements at play. When temperatures rise, the combustion process becomes more fervent, influencing the shades that emerge. For instance, a bright orange flame may signal a moderate temperature, while a blue hue suggests a hotter, cleaner burn. The materials that feed the fire also contribute to this colorful display. When certain metal ions are present, they can ignite special colors. Strontium showcases a vibrant red, while copper brings forth green. Each flicker and glow serves as a gentle indicator of the chemical compositions involved. As the fire consumes its fuel, the interplay of heat and material unfolds in these colors, painting a vivid yet transient picture. This interplay offers a glimpse into the hidden processes of combustion, where chemistry and temperature harmonize, flowing together in a beautiful display that is both mesmerizing and ephemeral. The gentle flicker of a fire reveals a process of energy release that unfolds quietly through the chemical reactions during combustion. When fuel ignites, it creates a warm glow and heat that radiates outward, a comforting presence in its surroundings. This energy release initially occurs at a steady pace. Flames consume the fuel, breaking it down and allowing the release of energy in the form of light and warmth. As time passes, the fire begins to draw closer to the limits of its fuel supply. The vibrant flames may start to soften, shifting from bright bursts to a calmer, slower burn. This transition often indicates a decrease in energy output, as the reactions that produce the light and heat begin to wane. The fire may start to smolder, emitting a gentle heat, but less brightness as it devours the remaining materials around it. Eventually, the dance of the flames comes to a pause, leaving behind embers that quietly glow. This soft light is a final reminder of the energy that once was, lingering for a moment before settling into stillness. The gentle transition from flames to embers reflects the gradual ebb and flow of energy, a natural cycle that invites rest and reflection. When fire consumes organic matter, a delicate transformation occurs, releasing carbon dioxide into the atmosphere. This process is a natural part of combustion, where the materials are broken down and the carbon stored within them is transformed. As the fire burns, the organic material steadily releases its energy, converting it into heat and light. At the same time, gases are emitted into the air. The release of carbon dioxide plays a significant role in the long-term composition of the atmosphere. Each flicker of the flame carries with it traces of this gas, altering the delicate balance that exists within the air around us. Over time, these changes can accumulate, influencing the environment in subtle ways. The connection between fire and carbon dioxide is a reminder of the natural cycles at play. Each moment of burning, followed by the release of gases, contributes to an ongoing exchange within the atmosphere. This gentle ebb and flow is part of a larger rhythm, reflecting the interconnectedness of all elements in nature. The soft whisper of the fire blends with the subtle changes it brings, inviting a sense of calm continuity. Fire carries warmth in many ways, and one of the quiet methods it uses to spread is through conduction. In this gentle process, heat moves through materials, traveling from a warmer object to a cooler one, igniting new sources of flame without the need for direct contact with an open fire. The warmth radiating from a smoldering log or the heat absorbed by sun-soaked rocks can create conditions perfect for ignition. In the landscape of a wildfire, dry grasses, often parched by the sun, may not directly contact flames, yet they can begin to burn from this transferred heat. The grasses draw in the warmth, and in a quiet moment, they transform from cool green life to flickering embers. This method of spreading highlights the delicate nature of fire's existence in the environment. It demonstrates how interconnected everything is, where even the absence of flames can ignite a chain of fiery transformations. The slow dance of heat moving through materials continues, quietly shaping the landscape and the life within it, inviting a sense of calm as the cycle unfolds. The nature of fire dances quietly through the intricate world of molecules that make up fuels. Each type of fuel possesses a unique arrangement of molecules, shaping how it interacts with heat and air. This internal structure determines how easily it ignites, how quickly it burns, and how much energy it releases when it does. For instance, one set of molecules may facilitate a rapid release of energy, resulting in a lively flame that flickers and crackles. Another arrangement might smolder softly, releasing heat slowly as it takes its time to transform. Some fuels with tightly packed molecules may take longer to ignite, while others enter a fiery embrace with the gentlest encouragement. This variation in molecular arrangement plays a crucial role in the rhythms of fire, influencing everything from the color of the flame to the smoke it produces. Understanding these structures reveals the subtle balance within the fuel as fire draws upon the invisible energy stored within. The peaceful interplay of these tiny particles continues to unfold, whispering the story of energy and transformation in each gentle flicker. The delicate nature of fire reveals an intricate balance that depends on heat, fuel, and oxygen. Within a particular range, these elements harmonize to sustain the gentle flicker of flames. Each component plays a distinct role, contributing to the ongoing process of combustion. A specific amount of heat is necessary to break down the molecular bonds within fuel, allowing it to release energy. This energy ignites, creating the initial spark needed for the dance of fire to begin. When fuel is plentiful and well structured, it effortlessly joins the cycle. Similarly, oxygen acts as a vital partner in this interplay. When there is enough oxygen surrounding the burning material, it supports the combustion process. Yet, if one of these components strays from its optimal threshold, the balance falters. Too little heat can cause fire to slow and eventually extinguish, as the fuel can no longer release energy effectively. Conversely, an excess of heat or a lack of oxygen may lead to incomplete combustion, bringing forth smoke and soot rather than a clean flame. This gentle system thrives within its boundaries, showcasing the beauty of stability and the quiet intricacies that govern the existence of fire. Always in a state of balance, each flicker of light whispers a soothing reminder of the harmony found in nature's simplest elements. Within the complex dynamics of combustion, there exists a phenomenon known as backdraft, which occurs when a smoldering fire is introduced to a sudden influx of oxygen. In a space where flames have retreated or diminished, the air can become heavy with smoke and unburned gases, creating a precarious environment. When conditions are just right, the arrival of fresh oxygen can reignite these lingering gases. The combination of heat and fuel, previously stifled, can rapidly transition into an explosive flare of fire. This event is rare and requires a very specific situation to occur, but its potential impact is significant, particularly within confined spaces. The interplay of hidden embers and descending smoke creates a tense atmosphere where a single shift in airflow can change the landscape of the fire entirely. As oxygen floods in, the dormant energy within the space awakens, resulting in a sudden burst of flames. Understanding this process emphasizes the delicate balance that governs combustion, showcasing how quickly the environment can change when subtle conditions align. The quiet intricacies of this interaction remind us of the power held within the simplest elements, gently whispering the importance of maintaining awareness of the surroundings. The dynamics of air affected by fire create a gentle but powerful interplay of forces. When a fire burns, it generates heat, causing the air around it to rise. This rising hot air creates a region of lower pressure, which can influence the surrounding atmosphere. The cooler air, with its slightly higher density, begins to move toward this area of reduced pressure, establishing subtle wind patterns. This airflow, although soft at first, can gather strength over time. As the hot air ascends, it can draw in cooler air from the periphery, drawing in additional oxygen that feeds the flames. These movements of air can extend well beyond the immediate vicinity of the fire, creating currents that can guide the flames as they dance and spread. The combination of heat and air movement illustrates a delicate balance. It shows how one natural process can set off another, each influencing the other in a continuous cycle. The understanding of these interactions highlights the intricate relationship within fire dynamics, where the very act of burning influences not just the immediate environment, but also the air's behavior around it. Such gentle fluctuations embody the beauty and power of nature, reminding us of the quiet cycles that exist within our world. In the passage of time, forests endure the cycle of fire, an event that, while fierce, plays a significant role in shaping ecosystems. As fires occur repeatedly over many years, the trees within those forests begin to face challenges. Their ability to withstand the heat diminishes, making it difficult for them to thrive. With each burn, a reset happens in the seasonal cycle, favoring plants that adapt well to these conditions. Gradually, grasslands can emerge where once stood dense forest. Grasses and small resilient plants often sprout more readily after a fire, taking advantage of the open space and the nutrient-rich soil left behind. These plants typically have deeper root systems, allowing them to draw on moisture even as the landscape changes. Over time, the resilience of these grasses can dominate the ecosystem, leading to a lush but different habitat. This gentle transition illustrates nature's ability to adapt, showcasing how repeated fire events can foster new life. The cycle of growth and rebirth continues, reflecting a quiet transformation that unfolds slowly. It reminds us that environments are fluid, continually shaped by their own inherent processes, evolving through time while remaining open to the stories they carry forward. Through careful management of landscapes, controlled burns emerge as a gentle yet effective method for supporting ecological balance. By intentionally igniting small, manageable areas, the forces of fire can be guided in a way that mimics natural processes. This management helps to reduce the buildup of dense underbrush and dry materials that can fuel larger, more uncontrollable wildfires. In this way, the health of the entire ecosystem is nurtured. By reducing the risk of intense fires, a variety of plant species can flourish alongside one another. This promotes biodiversity, as different life forms find their place in the mosaic of habitats created by the burn. Grasses, shrubs, and young trees each play a role in the renewal process, providing food and shelter for diverse forms of wildlife. With each cycle of controlled burning, the landscape adapts, creating a space where resilience can thrive. The gradual dance between fire and growth weaves an intricate pattern in the scenery, subtly enhancing the life found within. It allows an ongoing story of regeneration, where each flame carries the promise of a new beginning, gently unfolding the natural world before us, ready to continue into the vastness of its own rhythm. The nature of the fuel source plays a significant role in shaping the way a fire behaves. Different materials burn at various rates and temperatures, creating a spectrum of flames that are each unique in their movements. For instance, dry leaves and fine grasses catch fire quickly, flickering and dancing with a lively energy that fades as they consume their available fuel. In contrast, thicker logs burn more slowly, often becoming a steady, glowing ember that radiates warmth over an extended period. This variation in composition influences not only the speed of combustion, but also the stability of the fire's internal structure. When light, volatile materials ignite, they create a vibrant display. As those materials are consumed, the fire can shift, revealing the denser fuels beneath. These slower burning substances provide a foundation, allowing the fire to maintain itself even as some elements diminish. As the flames flicker and sway, each moment connects with the next, weaving an intricate tapestry of energy and transformation. This ongoing process continues quietly, each stage inviting a sense of rhythm within the space, patiently revealing the delicate relationships between fuel and flame. A gentle glow remains, indicating that each element, in its own time, contributes to the cycle of light and heat, allowing the story of fire to unfold in peaceful continuity. In certain environments, like peat bogs, fires can exist in a state of smoldering for long periods, extending over months and even years. This phenomenon arises from the unique characteristics of the materials found in these settings. Peat, composed of partially decayed organic matter, has a high carbon content and retains moisture. When ignited, the fire does not blaze in the typical way, but instead settles into a slow, quiet burn. The low oxygen levels in such dense and wet environments contribute to this smoldering state, where combustion occurs gradually. While visible flames might not always be present, the continued heat allows the fire to persist, quietly consuming the available material. Each moment, the smoldering fire interacts gentler with the peat, transforming its structure without fully reducing it to ash. As this process unfolds, the relationships between the fuel, moisture, and temperature create a delicate balance, fostering a unique cycle of energy. The fire continues this subtle dance, lingering within the earth, a soft presence amidst the rich ecosystem. With each slow breath, the quietness of the smoldering fire reflects the inherent patience of nature itself, continuing its story as time moves softly forward. Fire relies on a delicate balance of elements to maintain its presence. When exposed to excessive moisture, this balance begins to shift. Water can absorb heat, lowering the temperature necessary for combustion. As the moisture permeates the surrounding environment, it works to cool the flames, making it harder for the fire to sustain itself. This impact on temperature is significant, for fire thrives in conditions where warmth encourages the continuous release of energy from the materials it consumes. When dampness takes over, the smoke may thicken and the flames can flicker and wane. The resulting changes affect how effectively the materials burn, leading to incomplete combustion. As moisture infiltrates the surroundings, the fire can lose its vibrancy, becoming more subdued and less stable. This quieter state demonstrates how interconnected the elements of fire, air, and fuel truly are. Within this natural cycle, the fire continues to shape the landscape around it, retreating and re-emerging as the conditions shift, a gentle reminder of the flow inherent in the world around us. Certain structures possess inherent qualities that allow them to endure the effects of fire for significant lengths of time. These properties often stem from the choice of materials, which may have natural resistance to high temperatures. Certain metals, for example, can withstand intense heat without losing their shape or stability. The engineering of these buildings incorporates careful design, ensuring that the components work together harmoniously. In these constructions, fire-rated walls, floors, and ceilings serve as barriers, effectively slowing the spread of flames. Such designs allow for a continued structural integrity, even under the stress of extreme conditions. As the fire rages outside, these protective aspects work together, offering a sense of reassurance through their steadfast resilience. The characteristics of this protection contribute to an atmosphere where occupants may find a measure of safety amid uncertainty. In this way, the interplay of materials and design harmonizes to create a space that stands, calm and composed, through the trials of fire, ready to accompany the passage of time and the shifting elements. Flame speed describes the pace at which a flame moves through a combustible gas, and this rate is influenced by various factors. Under different conditions, the flame can travel anywhere from about 0.1 to 10 meters per second. A variety of elements contribute to this variability, including the type of gas involved, the temperature of the environment, and the pressure surrounding the flame. In a controlled setting, where gases are warm and mixed evenly, the flame speed can reach higher rates, dancing rapidly as it consumes the fuel available. Conversely, in cooler or denser environments, the movement slows significantly, the flame appearing languid as it makes its way through the air. As these chemical reactions occur, the gentle flicker of the flame reflects the intricate balance of energy, creating a vivid display of light and warmth. The behavior of the flame showcases a careful dance of particles as they energize, combine, and release energy. Each situation, unique in its dynamics, allows flames to express these subtle characteristics, maintaining a tranquil presence within the broader interplay of elements. Over countless years, fire has played a subtle role in shaping the characteristics of certain plant species. As wildfires occur, they create cycles of renewal in ecosystems. Some plants have adapted to these events through specific traits that enable them to survive and even thrive. Thick bark serves as a protective layer, shielding the vital inner parts of trees and allowing them to endure the heat of flames. This adaptation ensures that, while the outer surface may be scorched, the heartwood remains intact, ready to regenerate when conditions improve. In addition to protective bark, other plants have evolved seeds that require exposure to intense heat for germination. This warming period breaks down tough seed coats, signaling that the environment is welcoming for new growth. These seeds lie dormant, waiting patiently for just the right moment, a moment that can only come after the flames have passed. Through time, this intricate relationship has facilitated a delicate balance, where fire acts not just as a destructive force, but also as a catalyst for life, ensuring the continuation of species through adaptation and resilience. This dynamic process unfolds over generations, quietly shaping ecosystems and allowing nature to mend itself in gentle harmony. Periodic volcanic eruptions possess a unique ability to reshape the environment, influencing fire cycles and altering climate conditions in profound ways. When a volcano erupts, it releases ash and gases into the atmosphere, often resulting in temporary cooling or heating effects across vast areas. This shift can change precipitation patterns, which in turn affects the vegetation and the soil moisture levels. Such changes may create drier conditions that can elevate fire risks in certain regions. For many years following an eruption, the landscape may experience shifts in temperature and moisture, setting the stage for potential wildfires. Areas that were once moist and lush may become more arid, while others might face increased growth of flammable vegetation, all depending on the specific climatic changes triggered by the volcanic activity. These adjustments can ripple through ecosystems for a decade or more, creating an environment where fire can ignite more readily. The interaction between volcanic eruptions and fire cycles illustrates a delicate balance, where nature's forces intertwine, influencing one another over extended periods. This continual interplay adds to the intricate tapestry of life, reminding us of the complexities that govern ecosystems and their responses to changing conditions, welcoming the flow of time and transformation. The gentle motion of flames offers a unique interaction with the surrounding air. As fire dances and flickers, it creates turbulence that stirs the atmosphere. This movement is not merely a show, it plays a role in the natural world. The warm air rising from the flames creates currents that can lift and carry small seeds or spores from nearby plants. In this way, The ideal conditions for dispersal are fostered through the very act of burning. Seeds and spores, often lightweight and resilient, can find themselves swept away by these currents. As flames burn and shift, they can transport these tiny life forms across distances they might not reach through still air. The swirling eddies promote a scattering of life that might flourish in new locations, beginning a cycle of growth anew. This intricate connection highlights how fire, a force of transformation, also facilitates the continuation of life in diverse ecosystems. Through this gentle motion, flames not only transform their immediate environment, but also create opportunities for renewal and regeneration. As the cycles of nature intertwine, a sense of calm permeates, allowing all forms of life to find their place in the ever-changing landscape. The gas produced by fire, which includes primarily carbon dioxide and water vapor, is lighter than the surrounding air. This difference in density allows flames to ascend gracefully, carrying with them the warmth and energy generated by the burning fuel. As flames flicker and swirl, they interact dynamically with the air, creating a gentle rise that invites curiosity about the nature of combustion. Over time, as the fire consumes its fuel source, the gases produced may vary. The efficiency of combustion plays a crucial role in determining the density of these gases. In moments of high efficiency, the byproducts can remain lighter, allowing flames to rise steadily. However, changes in airflow or fuel quality can alter this balance, producing denser mixtures that may affect the motion of the fire. The continuous combustion process creates an ongoing dance between the flames and the air around them, a gentle exchange of energy and materials. This relationship fosters a rhythmic cycle as the fire adapts to its environment, with rising gases creating a soft whisper of movement. The quiet interaction of the fire with the surrounding atmosphere weaves together an intricate tapestry of energy transformations, sustaining the flames even as they shift and change. This tranquil, ongoing process emphasizes the beauty of natural phenomena, flowing peacefully onward, inviting further exploration into the wonders of the world around us. Over centuries, the occurrence of wildfires shapes the landscape in subtle yet profound ways. As fires sweep through an area, they create an environment where certain plant species can thrive. Some plants have evolved remarkable adaptations that enable them to withstand the heat and smoke, allowing them to regenerate quickly after a fire. These resilient species often produce seeds that require heat to germinate, ensuring their growth in the nutrient-rich soil left behind. In contrast, other plants may lack these adaptations and struggle to survive in the aftermath of repeated fires. Over time, these species may decline, unable to compete in the transformed landscape. This cycle of fire and recovery can lead to a gradual shift in species composition. As each fire passes, the diversity of the plant community evolves, sometimes favoring hardier, fire-adapted species over those that cannot cope with the changing conditions. The interactions between fire and vegetation create a dynamic ecosystem where the physical environment is in constant flux. This interplay encourages the overall health of the landscape, cycling nutrients and reshaping habitats. With each passing season, the forest regenerates, reflecting the enduring effects of fire. The underlying rhythms of nature continue, ever transforming, inviting us to observe the intricate connections between fire, plants, and the land they inhabit. The release of carbon dioxide from wildfires forms a notable cycle that intertwines with the long-term patterns of our climate. As vegetation burns, carbon that has been stored in plants for years is released back into the atmosphere. This process contributes to the overall carbon cycle, which plays a vital role in regulating the Earth's temperature. Each fire contributes to this slow dance of gases, reflecting a natural rhythm that unfolds over many decades. This cycle of carbon release aligns with significant intervals, often repeating roughly every 100 years. Over time, human activity has become more pronounced, further influencing the atmospheric composition. As forests experience more frequent wildfires, the amount of carbon dioxide released has increased, intertwining with the effects of industrialization and urban development. The consequence of this cumulative effect gradually shapes our climate. The balance between carbon capture by forests and the emissions from fires is delicate. It weaves into a larger story of ecological change, where the natural world responds to both fire and human impact. Through this continuous cycle, the atmosphere and climate evolve quietly, always in motion, reflecting the interplay of environmental forces. The tranquil patterns of nature persist, inviting deeper contemplation of our shared planet. Within the arid expanses of deserts, the role of fire presents a unique aspect of ecological evolution. In these dry regions where water is scarce and life can be tenuous, some plants have adapted to rely on the occasional warmth from fire to germinate. These seeds, nestled in the soil, often remain dormant until the temperature rises. When a fire sweeps through the landscape, it provides the heat necessary for these seeds to awaken and sprout. This process can lead to an increase in plant diversity over time. As various species respond to the cues from fire, they emerge into a world that has been cleared of old growth. The nutrients released by the ash enrich the soil, creating fertile ground for new life. This intricate relationship fosters a dynamic ecosystem, allowing a variety of plants to take root. Over many seasons, this cycle can contribute to a rich tapestry of life, with different species thriving under the unique conditions. The gentle rhythm of fire, although sometimes destructive, weaves into the fabric of desert life, encouraging resilience and diversity among plants. Each blooming season tells a story of transformation, ongoing and interconnected, inviting contemplation of nature's quiet serenity. In the realm of fire, a fascinating range of temperatures exists, typically spanning from 600 to 1,500 degrees Celsius. This variation largely depends on the materials being consumed and the amount of oxygen available to sustain the flames. As different substances ignite, they create distinct interactions within this temperature spectrum. For instance, wood may burn at a lower intensity compared to more flammable materials, each generating heat that contributes to the overall dynamic nature of the blaze. The presence of oxygen plays a pivotal role in maintaining a fire. When plentiful, it fuels the combustion process, allowing the flames to grow and thrive. Yet, as the fire consumes its fuel, both the material and oxygen begin to diminish. This limitation conveys a delicate balance, requiring just the right conditions for a fire to continue burning steadily. The dance of heat and oxygen influences not only the temperature, but also the behavior of the fire itself, shaping its flickering form and the way it interacts with the surrounding environment. In this quiet interplay, the essence of fire unfolds, revealing patterns and rhythms that resonate through the materials it consumes, inviting a sense of wonder at the sheer simplicity of these elemental forces. The act of burning yields a gentle release of heat, transforming chemical energy into thermal energy that radiates into the surrounding space. This process occurs as materials ignite and undergo combustion, creating warm air that rises softly, enveloping nearby surfaces. As fire consumes its fuel, it generates warmth that can influence various neighboring substances, affecting their temperature and physical state. The heat produced by the flames creates an environment where nearby materials may begin to react. This can cause changes, like the warming of metal or the softening of wax. Such reactions reveal the intricate relationships among different materials, each responding uniquely to the energy emitted by the fire. Some substances may absorb this warmth eagerly, while others might reflect or dissipate it, maintaining their distance from the heat. This transfer of energy is a quiet reminder of the interactions that occur in nature. As the surrounding air warms and shifts in temperature, a subtle dance unfolds, influenced by the warmth cascading from the flames. The process continues, evolving gracefully as the fire burns, inviting contemplation of the gentle flow of thermal energy that surrounds it. Crown fires occur in forests where the tops of trees burn with a fierce intensity, creating a quick-moving wall of flames that dances through the canopy. In optimal conditions, these fires can spread rapidly, traveling between the branches with a remarkable ease. The flames leap from one tree to another, capturing energy from each source and feeding on the moisture and materials found in the leaves and limbs above. This type of fire thrives when the air is dry and the trees are closely spaced, allowing it to move swiftly through the treetops, creating a fiery path high above the ground. The heat generated by the raging flames can create a hot draft, drawing in cooler air from below and fostering a cycle of movement that propels the fire forward. The interaction between the fire and the abundant foliage can lead to a unique phenomenon where the trees not only burn but also contribute to the ecological balance. Observing this behavior, one can appreciate how crown fires reveal the dynamics of thermal energy and fuel, showcasing the intense relationship within the ecosystem. Each flicker of the blaze tells a silent story of energy transfer and environmental interplay as the fire navigates the forest canopy, creating a vivid display of nature's intricate patterns. The cycle continues, revealing the resilient and sometimes fierce connection between elements in the wild. The El Niño Southern Oscillation, often referred to as ENSO, is a natural phenomenon that profoundly influences climate patterns around the globe. This cycle involves fluctuations in sea surface temperatures in the Pacific Ocean. As these temperatures change, they can alter weather systems, which in turn affects fire activity in many regions. Every 2 to 7 years, when the sea surface temperatures rise during an El Niño event or dip during a La Niña, a shift occurs in precipitation and moisture levels. Drier conditions can lead to an increased risk of fires, while wetter periods may help suppress them. These variations in climate create a rhythm, contributing to cycles of fire activity that can span several years. The interaction between the ocean and the atmosphere is intricate, affecting temperature, humidity, and wind patterns over vast distances. This interconnectedness highlights the delicate balance within ecosystems, where each element plays a role in shaping the environment. The impact of ENSO is a reminder of nature's complex systems, flowing seamlessly through time and space. The dance of climate and fire unfolds as part of a larger narrative in the world, with each cycle offering insights into the ongoing relationship between natural forces. In the gentle embrace of nature, certain grasses have developed remarkable adaptations to thrive in environments where fire is a recurring presence. These grasses possess deep root systems that anchor them firmly into the soil, allowing them to access moisture and nutrients hidden beneath the surface. When a fire sweeps through these landscapes, it may seem harsh and destructive, yet these resilient plants are prepared for such events. After a burn, While other vegetation may struggle to recover, these grasses spring back to life, often producing new growth within a short period. Their ability to regrow quickly relies on the energy stored in their roots, which remain unharmed beneath the charred surface. This subterranean resilience ensures that they continue to flourish even in the wake of flames. Fire, in this context, isn't merely a force of destruction, it plays a role in shaping the ecosystem that supports these grasses. As their new shoots break through the soil, they contribute to the overall health of the area, creating a cycle of regeneration. This intricate dance between fire and plant life weaves a complex tapestry of resilience and renewal, ensuring that life persists through the cycles of nature. The relationship between grasses and fire showcases the remarkable adaptations that allow life to endure, embracing the rhythms that nature provides. In the quiet rhythm of nature, fire plays a significant role in the carbon cycle, a process that unfolds over long periods of time. When forests ignite, the flames consume not just the trees, but also the carbon that has been stored within them for many years. This release of carbon into the atmosphere occurs in a series of invisible exchanges, where the solid structures of wood transform into gases, spreading through the air and contributing to the larger dynamics of climate. As this carbon dioxide mingles with the atmosphere, it becomes part of a complex web of interactions that can influence weather patterns and temperatures over decades or even centuries. Over time, as the cycle continues, new growth emerges to take the place of what was lost. Young trees begin to absorb carbon from the air, slowly reestablishing the balance. Their roots extend into the soil, collecting nutrients and nurturing the ground for future growth, while locking away carbon once again. This ongoing cycle reveals how intertwined life is with elemental forces like fire, showcasing a balance that, although seemingly disrupted by flames, finds a way to restore itself. It underscores the rhythm of renewal, where destruction and creation coexist, supporting the cycle of life in a delicate yet persistent manner. Nature unfolds at its own pace, ready to continue its quiet dance of growth and change. In the serene embrace of nature, repeated fires can foster a cycle of regeneration for specific plant species that flourish in the aftermath of such events. As the flames clear away older vegetation, they create a space where sunlight can reach the soil more freely. This moment of openness allows seeds, often lying dormant beneath the surface, to awaken and grow. These seeds are adapted to thrive in conditions shaped by fire, developing to take advantage of rich, nutrient-laden ash left behind. Over time, these resilient plants increase in number, establishing themselves in the landscape. With their growth, they stabilize the soil and encourage new forms of life to flourish. This process gradually transforms the area, creating a diverse ecosystem that supports various organisms. The cycle of fire and regeneration shapes the land, making it not just a recovery from destruction, but a pathway to renewal. As such cycles unfold, the landscape becomes an ever-changing tapestry, woven by these natural rhythms. In this way, the interplay of fire and flora nurtures balance, quietly orchestrating growth, while allowing nature to move through its many stages. The gentle dance of regeneration patiently lingers, inviting exploration of the quiet mysteries that unfold with each passing season. The gentle warmth radiating from a fire extends beyond its immediate flames. This heat seeps into the surrounding vegetation, gradually drawing moisture from leaves and stems. As plants lose their hydration, they become more vulnerable to the risk of future fires. This alteration in moisture levels can result in a significant change in the local ecosystem. Over time, those once thriving plants might find it challenging to recover, leading to shifts in the balance of species present in the area. As some plants dwindle, others may begin to dominate, leading to a reconfiguration of the landscape. This process does not happen overnight. Instead, it unfolds slowly, with each season marking subtle changes and adaptations. The persistent cycle of drying and the potential for subsequent fires creates a delicate feedback that influences not only the plants, but the entire ecological framework. Animals and microorganisms also adjust to these transitions, creating a dynamic environment where life continues to adapt. In this quiet dance of change, the interactions of fire and vegetation shape a landscape rich with complexity, inviting contemplation of its ongoing transformations. Each moment adds to a tapestry of existence, gently reminding us of nature's undeterred ability to persist and evolve. Fires in mineral-rich regions create significant transformations beneath the surface. The intense heat from the flames can alter the chemical composition of the soil, breaking down complex compounds and releasing essential nutrients. As these minerals become available, they begin to enrich the ground for years to come, fostering an environment ripe for new growth. In the aftermath of a fire, the soil remains infused with these newly available nutrients. Over time, this can stimulate the growth of various plants, encouraging a diverse array of species to take root. Some plants have adapted to thrive specifically in these nutrient-enhanced conditions, taking advantage of the resources released during the fire. As the years pass, the landscape gradually changes, with each season contributing to the ongoing cycle of renewal and regeneration. Life begins to flourish anew, each plant contributing to a complex web of interactions that create a vibrant community. This slow, natural recovery process speaks to the resilience of ecosystems, illustrating how fire, while destructive in the moment, can also be a catalyst for reawakening and abundance. As time unfolds, the soil tells a story of both change and continuity, a gentle reminder of nature's eternal rhythm, patiently waiting for the next chapter to emerge. The ash that lingers after a fire holds within it a quiet complexity, composed mainly of carbon. This residue represents energy that has been transformed, yet remains within the environment. As the ash settles gently upon the earth, it becomes part of the soil's fabric, blending seamlessly with other elements. Over time, this carbon can undergo various natural processes, finding its way into new forms. Microbial life in the soil plays an essential role in this transformation. Various organisms begin to break down the ash, utilizing the carbon for their own growth and energy. This slow exchange creates a symbiotic relationship where nutrients are cycled through the ecosystem. These tiny life forms, almost invisible to the naked eye, are busy at work, weaving the remnants of the fire into the rich tapestry of life below the surface. As seasons change, the carbon in the ash can be absorbed by plants, transforming into new growth. Each leaf that unfurls above ground is part of a delicate process, illustrating how energy is never truly lost, but rather reimagined in endless forms. With each passing moment, this ongoing cycle whispers of life's remarkable ability to adapt and flourish, hinting at stories yet to be told in the depths of the earth. The prevalence of fire in certain ecosystems plays a subtle yet significant role in determining which animal populations flourish. In areas where fire occurs regularly, species that have adapted to these conditions may find an abundance of resources. The striking landscapes left in the wake of flames often reveal open spaces, rich in new growth and nutrients. These changes create environments where particular species can thrive, taking advantage of the fresh resources that emerge after a fire passes. In contrast, the habitats that once supported animals dependent on dense vegetation begin to shift. As the landscape alters, species that rely on thick cover for food and shelter may find themselves at a disadvantage. The transformation of their habitat means they must adapt quickly or risk declining in number. This process unfolds over time, a gentle dance of adaptation and adjustment that is part of the natural rhythm of life. Within these fire-affected areas, important dynamics take place. As new life pushes through charred remnants, a variety of species interacts in ways that reshape the ecosystem. Populations fluctuate, and with time, balance is sought anew among the various creatures coexisting in this subtly changing world. The quiet hum of life continues, ever responsive to the rhythm set by nature's own cycles, inviting reflections on the enduring resilience of living systems. The gentle process of combustion involves a steady release of energy, a reflection of the chemical reactions occurring within a burning substance. When these reactions are stable, they can produce a consistent output of energy. This stability creates a harmonious cycle where the fuel continues to burn steadily, allowing for a reliable release that can be closely monitored and managed. In such environments, the heat generated from the combustion fosters a warm glow, while the combustion byproducts, like steam and gases, quietly rise and disperse. This steady energy flow can be observed in facilities designed to harness bioenergy, where plant materials and other organic substances transform into a source of power. Each element interacts within this process, allowing the energy to be drawn off in a controlled manner. As the combustion continues, energy management becomes vital, ensuring that the release remains steady without significant fluctuation. The ongoing dance of particles and energy fosters an equilibrium, a soothing rhythm that supports the sustainability of energy production. In this tranquil setting, the elements of nature combine effortlessly, each contributing to a continuous cycle of energy release and transformation. The soft, muted sounds of energy generation blend seamlessly with the quiet, allowing thoughts to drift softly into an ever-expanding horizon of possibilities. Fire, in its quiet power, has a profound ability to reshape landscapes over the passage of time. When it sweeps through a region, it alters the very fabric of the environment. The initial devastation gives way to a slow transformation as the land begins to heal. Some plants have evolved to thrive in this post-fire world, sprouting quickly from the nutrient-rich ash that remains. Their seeds often lie dormant, waiting for the right conditions to awaken. As these first plants emerge, they invigorate the soil, creating a nurturing bed for new life. Over the years, a new ecosystem begins to develop, layering itself over the remnants of the old. Smaller plants may quickly establish themselves, providing shelter and nourishment for insects and small animals. Gradually, these initial verdant displays pave the way for larger shrubs and trees to populate the area, creating a tapestry of growth and renewal. The cycle continues, with each season bringing subtle changes. The landscape, once marked by scorched earth, becomes a mosaic of resilience. This transformation occurs quietly, a gentle reminder of nature's ability to adapt and restore. Time flows softly, and the world shifts into balance, allowing new life to flourish quietly beneath the surface. As the ecosystem grows stronger, it whispers a promise of continuity, nurturing both the land and all who dwell within it. This serene process unfolds endlessly, inviting reflections on change and resilience. At high altitudes, the air becomes thin, which affects many physical processes, including combustion. In these lofty heights, the oxygen content diminishes, making it increasingly challenging for fire to ignite and sustain itself. This delicate balance of elements reveals the boundaries of how fire interacts with its environment. The flames, if they manage to spark, burn with less intensity, flickering gently as they struggle against the surrounding atmosphere. Because of the reduced oxygen, fires can appear to dance in a different rhythm, often consuming fuel at a slower pace. The materials that accompany these flames may remain partially charred, as combustion is dependent on a rich blend of air and heat. The intimacy between the fire and its surroundings becomes apparent as each breath of wind brings momentary changes, coaxing or dousing the flickering reaches of flame. In this unique setting, the fragile interplay of elements showcases how fire adapts, responding to the limitations of its environment. It invites contemplation of the natural world's intricate systems and how they function harmoniously, even under challenging conditions. Observing this gentle struggle offers an understanding of fire's persistent nature, quietly reminding us of the beauty found in the simplest interactions. The quiet whispers of the universe unfold, leaving a sense of continuity and wonder in their wake. Inside a fire, combustion ideally occurs when there is an ample supply of oxygen, allowing materials to burn cleanly and efficiently. When the oxygen is insufficient, however, the process becomes uneven, leading to what is known as incomplete combustion. This divergence results in the formation of soot, a collection of tiny carbon particles that gather within the flames. As flames flicker and dance, they may produce thick clouds of this soot, which can settle on surfaces nearby. The essence of soot reflects the complexities of fire as it navigates varying conditions of air and material, revealing a kind of quiet struggle. The finer details of soot's formation underscore how important oxygen is for fire's energy transformation. When combustion occurs in poorly ventilated spaces, or where the fuel does not ignite completely, the carbon particles increase, gradually creating a darker, heavier atmosphere. This lingering residue serves as a reminder of the delicate balance required for fire to flourish and remain clear of impurities. It evokes an understanding of the intricate nature of chemical reactions at work, continuing to highlight the fascinating interplay of components that define fire itself. The faint wisps of soot floating softly in the air connect to the lingering warmth of the flames, leaving the mind to wander gently in the calm of this natural phenomenon. Within the body of a candle flame exists a quietly organized structure. At its center lies a stable core, where the wax transforms into vapor. This process begins when the heat from the flame draws the solid wax upward through the wick. As the wax reaches the flame, it encounters a high temperature, causing the wax to evaporate and form a gas. This vapor then moves into the surrounding areas of the flame, where it engages in combustion. The core serves as a vital anchor for the flame, providing a consistent source of energy while wax remains present. It creates a gentle equilibrium, allowing the flame to persist steadily as long as the wax feeds it. The combustion in this core produces heat and light, gradually consuming the wax as it maintains its central shape. As the candle continues to burn, the flames flicker in unison with the rhythm of the wax transforming and combusting. Each flicker is a reflection of the ongoing process within that stable core, creating a soft, soothing glow. This illuminating dance remains steadfast, painting a tranquil scene in the dim light, quietly telling the story of energy and transformation that unfolds with each passing moment. The warmth of the candle flame enhances the calm of the surroundings, inviting deeper relaxation and peace as it continues to softly shine. Each flicker of the flame brings forth a delicate display of electromagnetic radiation. This radiation emerges from the processes occurring within the fire, predominantly manifesting as visible light that dances softly in the air. The warm glow envelops the surroundings, creating an inviting ambiance. Alongside this light, infrared radiation is produced, a form that carries heat. This heat can reach out and be felt at a gentle distance, expanding the comforting warmth beyond the immediate confines of the flame. As the fire begins to diminish, the intensity of both the light and heat gradually decreases. The warm hues shift like the evening sky, softening and settling into deeper tones as the flame wanes. This gradual fading contributes to the peaceful nature of the scene, providing a sense of calm as the surrounding air slowly cools. The light dims gently, revealing the quiet rhythm of the fire's existence, a reminder of the balance it maintains within. Even as the fire lessens, the remnants of its warmth linger softly in the atmosphere, a quiet echo of the vibrant energy that once filled the space. This interplay of light and warmth invites a sense of tranquility, an experience to be appreciated as the moments of quiet unfold softly around it. The gentle flickering of the flames relies on a steady supply of oxygen, which it consumes in the process of burning. The rate at which fire consumes this essential element varies, influenced by the size of the flame and the type of fuel it is burning. Larger flames, with more fuel to sustain them, may engulf oxygen at a swifter pace, while smaller flames tend to draw it in more slowly. In an enclosed space, this consumption can lead to a notable reduction in the oxygen available within the surroundings. As the fire dances, it alters the very air around it, creating a feedback loop that shapes its behavior. However, in environments where conditions are stabilized, such as in a controlled setting, the fire can reach a balance. Here, its rate of oxygen consumption settles into predictable patterns, allowing the fire to flourish without rapidly depleting the atmosphere. The relationship between fire and oxygen is a quiet dance, an interaction that illustrates the delicate balance within its world. This balance lends itself to an understanding of how fire exists in harmony with its environment, attentively modulating its needs as it breathes life into the dimly lit space. With each breath, as the environment shifts, the flame continues its rhythm, an ever-present reminder of the intricate systems at play. Within the realm of fire, some flames become extraordinary in their behavior, leading to the formation of unique weather patterns known as fire whirls. This phenomenon arises when intense heat from a fire generates upward drafts that spiral in a circular motion. As the warmth rises, it interacts with the cooler air surrounding it, creating a gentle, rotating column that dances gracefully above the flames. In these moments, the fire is not merely a source of light and warmth. It transforms into a dynamic entity that can lift burning debris into the air, evoking imagery reminiscent of gentle tornadoes. The capacity for such whirls emerges from the delicate interplay between heat and airflow, making each occurrence a distinct and mesmerizing spectacle. These fire whirls, sometimes described as dragon's breath, carry with them the energy of the fire, allowing them to travel aloft with an elegance unique to their nature. The swirling motion captures the energy of the blaze, allowing for a mesmerizing display that harmonizes power with grace. In this dance of heat and air, the fire whirls reveal the intricate connections within the fire's world, illustrating how it communicates with its surroundings in a gentle yet profound way. Each whirl is a fleeting reminder of the fascinating behaviors within the flames, offering a momentary glimpse into the delicate balance of forces at play. In the aftermath of a forest fire, the landscape undergoes significant transformation, leading to shifts in the delicate balance of animal populations. Some species find themselves thriving within the newly charred environment. Certain animals, especially those that prefer open spaces, benefit from the removal of dense foliage. This change allows sunlight to penetrate more freely, encouraging the growth of new vegetation, which in turn provides a fresh source of food and habitat. Birds may return to the area, drawn in by the abundance of seeds and insects that emerge in the wake of the fire. Ground dwellers, like small mammals, may also find the altered terrain more suitable, as the absence of cover makes it easier to forage and breed. Yet, not all are destined to adapt. Some animals, reliant on more sheltered plant life, might vacate the area, seeking refuge elsewhere. This voluntary departure can lead to a gradual decline in populations that depended on the former structure of the forest. As time passes, ecosystems begin to shift, revealing the dynamic nature of life in response to fire. The landscape slowly heals, allowing for new interactions and relationships to form among the species that remain. In this gentle cycle, the forest whispers of resilience, quietly nurturing both change and continuity as it rebuilds. Each transformation is part of the natural rhythm, echoing the enduring connection between fire, land, and life itself. The process of combustion in a fire involves a complex transformation of materials. As wood, leaves, and other organic substances burn, they undergo chemical changes that result in the release of energy, light, and heat. This consumed mass, while substantial, ultimately leaves behind a trace of its existence in the form of ashes and gases. When a fire concludes, it may seem as though much has been lost, yet this shift aligns perfectly with the law of conservation of mass. In this natural cycle, materials are not truly destroyed, rather they change form. The solid remnants, the ashes that settle upon the earth, carry the essence of what once was. Gases released into the air disperse quietly into the atmosphere. It is a gentle reminder of how matter continually reshapes itself, flowing from one state to another without vanishing entirely. What remains is a testimony to the fire's passage, an intricate balance of transformation that reflects the ongoing rhythms of nature. In this quiet aftermath, the environment breathes anew, gradually welcoming the next cycle of growth and change, allowing life the chance to flourish once more. The influence of fire on ecosystems unfolds gradually, leaving a lasting mark on the environment. When trees succumb to flames, the process does more than just consume the wood. As those trees burn, they release nutrients trapped within their structure. These nutrients settle into the soil, enriching it in ways that can promote new life. The ashes, fine and soft, contain essential minerals that were once part of the living trees. Potassium, phosphorus, and nitrogen blend into the earth, quietly altering its chemistry. Over time, this transformation allows for a revitalization of the landscape. Grasses and small plants begin to sprout, coaxed into growth by the enriched soil, establishing a new phase of life where once there were only embers. The cycle of renewal continues as these new plants draw sustenance from their surroundings, further shaping the ecosystem. The landscape gradually adapts, inviting a diversity of life to flourish. Through this slow dance of change, the soil becomes a nurturing foundation, rich with potential for the future. There is a quiet elegance in this process as nature reconnects and rejuvenates, allowing serenity to guide the passage of time. Certain tree species, particularly some pines, have developed remarkable adaptations to the presence of fire. Their cones are uniquely designed to respond to heat, remaining closed until the right moment arrives. When a forest fire sweeps through, the intense heat triggers these cones to open. This is not a hasty reaction, but rather a natural cue, signaling the time for new beginnings. With the fire's passage, the cones release seeds, gently scattering them across the freshly charred ground. This new layer of soil, enriched by the ash, becomes a nurturing bed for these seeds. The cycle of regeneration begins anew, typically unfolding every 5 to 20 years after a fire event. In this way, these trees contribute to a rhythm in the forest, allowing life to return in an orchestrated dance with nature. Young shoots emerge, stretching toward the sun, while the older trees create a canopy overhead, fostering a sanctuary for new growth. The landscape slowly transforms as life reestablishes itself, imbued with the silent promise of renewal. In this serene unfolding of nature, a gentle harmony settles over the land, creating a tranquil space ready for quiet reflection. Fire, with its warm embrace, can induce significant changes within materials through a process known as pyrolysis. This transformation occurs when organic matter is subjected to high temperatures, allowing it to break down even in the absence of oxygen. During this process, the heat initiates a gentle alteration, unwinding the complex structures of the organic compounds. As the temperatures rise, the volatile components vaporize, leaving behind a solid residue that is rich in carbon. This carbon-rich substance is known as charcoal. Charcoal, formed through this serene yet powerful process, captures the essence of the original material while transitioning into a new state. The pathways through pyrolysis also open avenues for creating biofuels, which can serve as energy sources derived from organic matter, further affirming the intricate relationship between heat and the materials it transforms. Each step in this process unfolds with a quiet precision, illustrating the natural cycles at play. These transformations, occurring out of sight, continue their gentle rhythm, creating new forms ready to contribute to the world. The stillness that follows is a gentle reminder of the continuous nature of change, always moving forward into a soft and tranquil future. Within the flickering dance of flames, a complex tapestry of chemical reactions unfolds, each one contributing to the ever-changing character of fire. As it burns, the materials within the fire are rearranged, transforming into new compounds while consuming the original fuel. These reactions take place in layers, overlapping and intertwining, reflecting a dynamic interplay that might go unnoticed in the moment. At the core of the fire, the heat facilitates a rapid series of combustions, generating a mixture of gases, some of which dissipate into the atmosphere. Others remain, suspended in the heat, temporarily altering the air's composition. This medley of byproducts can include ash, smoke, water vapor, and more complex substances that linger, affecting the surrounding environment. Even as the fire rages, its internal structure is continually reshaped, morphing from solid materials into luminous glows that shift and pulse with energy. Each reaction ebbs and flows, creating a cycle of creation and transformation that persists until the flames begin to dwindle. As the fire relents, a sense of stillness emerges, leaving behind traces of its journey through the elements, quietly preparing the stage for renewal. In the quiet expanse of grasslands, fire plays a subtle and vital role in shaping the landscape, moving through it on a gentle cycle that spans decades. These fire regimes, often occurring every 10 to 30 years, create a rhythm that nurtures the environment, allowing the earth to breathe and regenerate. As flames spread across the dry grasses, They consume the older, decaying plant material, returning nutrients to the soil. This periodic burning opens space for fresh growth, encouraging new plants to emerge. These younger plants, in turn, draw on the revitalized nutrients, enhancing the soil's richness. Each cycle transforms the landscape, fostering a delicate balance that sustains both the flora and the fauna that reside there. Microorganisms within the soil awaken from dormancy, participating in the renewal process, breaking down organic matter and enhancing soil health. The aftermath of fire leaves a landscape that is, at first glance, stark and bare. Yet, with time, the vibrant tapestry of green emerges anew. The cycle continues, a quiet melody of life and renewal, gently caressed by the whispering winds that carry the promise of regeneration. Within the heart of a fully developed flame, the temperature can ascend to around 1,100 degrees Celsius, or 2,012 degrees Fahrenheit. This intense heat arises from a complex interplay of chemical reactions, in which fuel combines with oxygen, producing energy in the form of light and warmth. As the flame dances, it consumes material around it, creating a swirling motion that carries heat and energy outward. In this environment, gases expand, and the air becomes laden with tiny particles. The flames flicker and sway, creating varied temperatures across different sections of the fire. While the core radiates intense heat, the edges cool slightly, allowing other processes to occur. This dynamic nature facilitates the emission of light, a spectrum that can shift in color from bright yellows and whites at the hottest points to softer reds and blues as temperature decreases. As the flame persists, its characteristics remain in constant flux, influenced by available fuel and airflow. The warmth of the fire radiates, softly illuminating the surroundings, while its life cycle continues, offering a quiet. In the aftermath of a fire, the landscape undergoes a profound transformation. As flames consume vegetation, they leave behind a charred environment that begins to shift over time. Dead trees, remnants of what once was, stand silently, eventually providing essential habitats for various species. Insects find refuge within the decaying bark, where they can thrive in the rich nutrients offered by the decaying wood. Birds may nest in the hollowed trunks, finding safe spaces to raise their young. This gradual return nurtures an ecosystem that supports a range of wildlife, drawing in those who thrive on the abundance of life that erupts from what might first appear as devastation. Over the years, seeds from resilient plants can take root in the nutrient-rich soil, fostering new growth and diverse plant life. The cycle continues as new organisms interact with the landscape, creating an ever-evolving tapestry of life. This interplay encourages adaptability and ensures that in time, the landscape flourishes once more, embracing the quiet rhythms of nature. Through the passage of time, fire plays a role in shaping unique ecosystems. Certain plants, known as fire-adapted species, evolve to depend on fire for their survival. These plants often have thick, protective bark, allowing them to withstand the heat. Some seeds even require the intense heat of fire to germinate, unlocking their potential only after the flames have passed. In this way, fire becomes a part of a natural rhythm, influencing the life cycles of various organisms. After a fire, these resilient plants can flourish, providing nourishment and shelter for a variety of animals. Herbivores thrive on the fresh, tender growth that sprouts in the wake of a fire, promoting a diverse food web. Predators, in turn, find ample opportunities in this rich environment. Over centuries, these interactions create a complex system where both plants and animals are interdependent, enhancing biodiversity. Each fire paves the way for new life, a gentle reminder of nature's enduring cycles. The ecosystem continues to evolve, responding to the ebb and flow of fire, harmonizing with the quiet heartbeat of the land. Within the flickering embrace of a flame, an extraordinary process unfolds. As combustion ignites, the heat transforms certain gases into a plasma state, a delicate balance where atoms lose their electrons. The resulting ionized gases shimmer with energy, creating the bright core that many recognize as the heart of the fire. This plasma possesses the ability to conduct electricity, a feature that adds to its unique characteristics. Sustained by a continuous supply of fuel, the stability of this plasma allows it to persist, as long as the conditions of heat and oxygen are met. The interplay of energy and matter weaves a complex tapestry that dances within the flames. Each flicker of light represents the dynamic interactions of these ionized gases, their charged particles swirling and intertwining. As the flame burns steadily, it serves as a reminder of the intricate processes occurring in its core. Its gentle warmth radiates outward, echoing the balance required to maintain the plasma state, fostering an environment defined by movement and transformation. In this quiet spectacle, the elements are engaged in a serene dialogue, illustrating the beauty of the natural world's processes. In the moment when wood succumbs to flame, a transformation begins, quiet and gradual. The heat from the fire penetrates the fibers, causing moisture trapped within to evaporate. This evaporation is not instantaneous. It unfolds slowly, requiring energy to escape the confines of the timber. As the water molecules transition from liquid to vapor, they leave behind a shift within the wood's structure. The fibers begin to change, becoming lighter and more brittle as their internal moisture diminishes. This loss of water affects the way the material behaves, altering its density and strength. Each droplet that escapes carries with it the essence of the wood, creating a gradual metamorphosis marked by the gentle crackling sound and faint wisps of steam that rise into the air. This process, subtle yet impactful, lays bare the intricate relationship between heat and matter. The ongoing dance of molecules that happens deep within the wood serves as a reminder of the changes continuously at play. The structure of the wood begins to realign, adapting to the energy that surrounds it, ready to embrace the next step in its journey through combustion. As the flame persists, these transformations continue in a serene rhythm, enveloping the wood in warmth and light, reflecting a quiet cycle of change and renewal. In the aftermath of fire, a quiet transformation begins in the landscape. With repeated events of flame, the lush green cover that once cradled the soil may diminish. The plants essential for holding the earth in place find their vitality stripped away, leaving the ground more exposed. As this protective layer thins, the soil becomes vulnerable, subject to the gentle caress of wind and the soft pattern of rain. With each passing storm, soil that once remained secure begins to wash away, a slow and steady erosion that alters the topography of the land. The absence of plant roots, which lock the earth together, means that particles become loose and easily displaced. Over time, the contours of the landscape shift, and the rich, fertile layer that supports growth can be diminished. As nutrients wash down the hillsides or are swept away by flowing water, the potential for future plant life wanes. Seeds struggle to take root in an environment that has been changed, their chances of flourishing diminished by the loss of the soil that supports them. This quiet, ongoing process reminds us of the delicate balance within ecosystems, where each change, however subtle, reverberates through time, affecting what may arise in the future. The earth remains, waiting patiently for the opportunity to renew itself once more. In the cycles of nature, fire plays a gentle yet profound role in the renewal of ecosystems. Over decades, specific habitats have adapted, relying on the cleansing heat of fire to clear away the remnants of old growth. The flames move softly through the underbrush, consuming the dry, dead materials that once occupied space, creating an opening for new life to emerge. In the aftermath, sunlight filters down to the soil, warming it as the air fills with the subtle scent of charred earth. This nurturing warmth awakens dormant seeds, which have patiently awaited their moment to sprout. With the removal of older plants, a fresh generation begins to take root, harnessing the nutrients released by the ashes. These nutrients, once locked away, return to the soil, enriching it and supporting new growth. As new plants establish themselves, they bring with them the promise of a diverse tapestry, inviting a variety of life back into the area. Over time, the landscape transforms, gradually shifting from charred remains to a vibrant ecosystem richly filled with various flora. This slow and steady process reveals the resilience of nature, forever cycling and renewing, ready to embrace the ebb and flow of life in an eternal, soothing rhythm. In the natural world, the occurrence of large wildfires often follows a cycle that can extend over approximately 20 years. This recurring pattern has roots deep within the ecological history of a region, shaped by a blend of natural processes and changes in the environment. Factors such as historical land use contribute to how fire behaves and spreads, creating a landscape that might hold on to more fuel than it can sustain. Forest management practices, too, play a subtle role in this cycle, influencing which areas are more prone to ignition and how likely they are to recover once the flames have passed. With each wildfire, the landscape undergoes a transformation, slowly returning to a state of balance, guided by small, consistent shifts in temperature and moisture levels over the years. As climate changes create new patterns of weather, the intervals between fires can also be affected, creating a dynamic rhythm. This seesaw of life and fire gently reshapes the terrain, allowing ecosystems to evolve gradually. In time, each fire becomes a thread in the intricate tapestry of life, leading towards renewal. Each cycle reveals nature's resilience as it prepares for the next harmonious awakening. When wood begins to burn, a transformation takes place, converting stored chemical energy into forms we can perceive. As the wood ignites, the heat triggers a series of chemical reactions. These reactions break down the complex molecules that make up the wood, allowing the energy contained within to be released. This process of combustion produces not only warmth, but also light, illuminating the surroundings in a gentle glow. The flames dance softly, signaling the release of energy as heat radiates outward. As these reactions continue, the wood gradually breaks apart, changing the structure and composition of the material itself. This gradual breakdown allows for a predictable rhythm of flames and embers as the energy moves from a solid state into the air, becoming a part of the atmosphere. Throughout this process, carbon dioxide and water vapor are formed, released into the environment, further contributing to the cycle of life. Each flicker of flame represents a moment of energy transformation, a calming reminder of nature's ongoing processes, quietly evolving and renewing itself in a serene, steady flow. The heat generated by fire travels outward, gently warming the space around it. This warmth can affect the materials nearby, causing gradual changes in their structure. As the temperature rises, Different components within these materials respond in varying ways. Metals, for instance, tend to expand uniformly, their particles moving apart as they absorb heat. This effect can lead to changes in shape, causing components to fit together differently over time. Wood also reacts, though its response can be a bit more complex. As it heats up, the moisture within can evaporate, leading to shrinkage in some areas, while other parts may swell slightly. This interplay can alter the integrity of the wood, affecting its strength and stability. Over time, repeated exposure to heat might even lead to cracking or warping. These subtle transformations occur slowly, often unnoticed, drifting in the background like a quiet breeze. The entire process reminds us of the gentle balance within the physical world, where heat flows and materials respond in calm, predictable ways. Each interaction adds to the intricate tapestry of change, unfolding slowly, inviting us to consider the makeup of the world around us. After the flames have faded and the light of fire is gone, the residue left behind remains. This material is often rich with the energy that once fueled the fire, a quiet reminder of its former intensity. This residual matter, whether ash or charred remains, holds within it latent energy, waiting patiently in the stillness. As time passes, small changes begin to unfold within this residue. Decomposition occurs slowly as microorganisms and natural elements interact with the remnants. These processes gently release the stored energy, transforming the materials in delicate, unseen ways. Erosion can also take its course, where wind and water work persistently to break down the remnants. This slow dance of nature enables the energy to re-emerge, seeping into the surrounding environment, feeding life and promoting growth. As this latent energy quietly finds its way back into the earth, it serves as a lasting testament to the powerful influence of fire. Each moment of change is subtle, yet profound, enriching the soil and the air with remnants of the energy it once held. In this continuous cycle, we observe the quiet resilience of nature, where even the remnants of a fire can nurture life in its own gentle way, unfolding softly and surely. The patterns of fire, subtle yet influential, unfold over centuries, creating ripples in the fabric of our climate. When larger areas ignite, the impact reaches far beyond the immediate surroundings. These expansive fires release vast amounts of carbon into the atmosphere, altering the delicate balance of gases that envelop the Earth. The heat from such events can contribute to rising temperatures, quietly shifting the climate over time. As ash and soot settle, they interact with the atmosphere, reflecting sunlight and affecting the planet's ability to absorb heat. Areas that experience frequent burning may develop a unique climate where the consequences of fire begin to merge with natural cycles. This interplay creates a rich tapestry of weather patterns influenced by the remnants of heat and energy released through combustion. Over extended periods, these changes may ripple through ecosystems, gradually transforming landscapes and climates in ways that are often imperceptible at first glance. The quiet power of fire lingers, shaping a world that continuously adapts, evolving alongside the rhythm of nature's cycles. As these patterns persist, they remind us of the intricate connections that exist within our environment, weaving a story of change that unfolds softly over time. The gentle heat generated by fire brings about a transformation in the air around it. As the flames flicker and dance, they warm the nearby air, causing the molecules within it to move more rapidly. This increased movement disrupts their stillness, creating pockets of warmer air that rise, buoyed by their own lightness. This phenomenon initiates a process known as convection, As hot air ascends, it leaves behind cooler air, which then moves in to take its place, creating a continuous flow. This movement forms convection currents, which carry heat, smoke, and even embers upwards from the source of the fire. These currents can subtly shape the behavior of flames, guiding them in sweeping arcs and gentle curls. The interplay of moving air and rising heat creates a dynamic environment, enriching the atmosphere in which the fire exists. With each flicker and pulse, the fire not only consumes material, but breathes life into the air, allowing it to shift and flow. The currents weave through the night, carrying warmth and light, painting a scene of quiet motion. As this dance persists, the air envelops the surroundings, offering a soft, unbroken rhythm that invites continued observation. Within the heart of a flame, an intricate structure emerges, characterized by layers that vary in temperature. At its center lies a cooler zone, where the process of combustion begins to take shape. Here, some gaseous materials gather, and the swirling movement helps to keep this area relatively temperate. Surrounding this inner zone is an outer layer, warmed by the reaction occurring within. This outer area radiates heat more intensely, often illuminating the flame and casting a gentle glow around it. The temperature gradient, from cooler to hotter, creates a delicate balance that shapes the flame's very form. Each layer interacts with the others, sustaining the behavior that we observe. As air is drawn in and heat radiates outward, the continuous movement of energy enables the flame to flicker and sway. Over time, this dynamic equilibrium allows flames to maintain their presence, each flicker a reflection of the interplay between these temperature zones. The dance remains fluid, with each oscillation adding to the soft rhythm of the night, leaving space for quiet contemplation and wonder. As fire consumes oxygen, it creates a remarkable phenomenon that alters the surrounding environment. The process begins as the flames draw in the vital air they require to sustain their presence. This consumption results in a drop in air pressure within the immediate vicinity of the fire. The reduction in pressure creates a subtle vacuum effect, an invisible force that beckons fresh oxygen from nearby areas. Fresh air, rich with oxygen, flows gently toward the flames, feeding them further and allowing them to grow. This cycle continues as the fire reaches out to pull in more life-sustaining air. In this way, the flames create an ever-changing dance, continuously drawing in what it needs to thrive. The interaction between the fire and the surrounding air unfolds quietly, depicting a harmonious cycle of use and replenishment. As the temperature rises and the flames flicker, that ceaseless movement lends a sense of fluidity and calm. Each moment flows into the next, a gentle reminder of the balance present in nature, awaiting exploration and understanding. Fire begins its journey at a specific temperature, known as the ignition point, which generally hovers around 300 degrees Celsius. At this temperature, materials start to reach a state where they can react with oxygen, leading to the release of energy in the form of heat and light. This critical threshold marks the moment when potential transforms into action. The molecules within the material begin to vibrate more rapidly, and as their energy rises, they become more capable of breaking free from their bonds, engaging with oxygen to create combustion. When these reactions spark, the fire can spread and grow, driven by the energy available in the surrounding environment. The heat generated not only sustains the flames, but also contributes to the temperature around it, inviting other materials to reach their ignition points as well. This process unfolds in a gradual and balanced manner as energy flows through the system, feeding the flames while remaining linked to the very materials that allow it to exist. The fire's relationship with temperature creates an ongoing dance of energy exchange, a quiet interplay that unfolds over time. With every moment, the heat radiates softly, extending its influence, fostering a natural rhythm that continues to influence its surroundings. This calming cycle, marked by the ignition point, serves as a gentle reminder of the delicate balance that exists in nature, patiently waiting to be explored further. Fire, with its intense and enduring heat, holds the remarkable ability to alter rock formations over vast spans of time. When large fires burn with sufficient intensity, their temperatures can reach levels that begin to affect the minerals found within the rocks. This heating causes changes at the molecular level, where the structured arrangement of elements might rearrange, giving rise to new mineral compositions. Over millions of years, the effect of these fires can create a tapestry of geological change. Rocks that once held a distinct form may transform, developing new physical characteristics and properties. The minerals react, some melting and others reforming, while the land itself may shift shape under the influence of heat and time. As layers of rock are exposed and reshaped, the echoes of ancient fires linger in the geological record. These subtle yet profound transformations reflect nature's continual evolution, marking a quiet yet powerful response to intense heat. The interplay of fire and rock shapes the Earth's crust, reminding us of the gentle, long-term processes that occur beneath our feet. Even as scene shifts and environments change, the impact of fire weaves itself into the story of the land, patiently waiting to reveal its effects over the ages. Within the heart of a fire, as materials burn, they release gases that fill the surrounding space. These gases do not merely dissipate, they expand rapidly as they heat up. This internal pressure builds quietly, a result of the increased volume of gases seeking more room to breathe. When conditions align perfectly, the pressure can reach critical levels, leading to an explosive release. This rapid expansion can result in bursts of flame that shoot outwards, often referred to as fireball effects. In an instant, the flickering calm of a fire can transform into a brief but intense eruption of light and heat. This phenomenon hinges on the interplay between the materials being consumed and the gases produced during combustion. The makeup of these gases can vary, leading to different types of bursts, each with its own unique characteristics. Such events, while startling, are part of the dynamic behavior of fire, a natural response to the energies at play. After the rapid outburst fades, the fire may settle back into its steady state, continuing to consume surrounding materials while the gentle crackling and flickering return. The cycle of combustion continues, embracing the calm rhythm of nature. In the vast interconnected tapestry of nature, solar activity plays a subtle yet significant role. Historical data reveals a connection between the cycles of the sun and the occurrence of major wildfires. As the sun goes through its cycles, typically lasting around 11 years, variations in solar radiation can influence weather patterns on Earth. This solar cycle affects not just the amount of light and heat received, but also the atmospheric conditions. During periods of heightened solar activity, changes in temperature and moisture levels can create environments more conducive to wildfires. Drier conditions may emerge, often accompanied by stronger winds, allowing fires to spread with greater ease. Earth's climate fluctuates in response, creating cycles of fire prevalence linked to these solar peaks. As the sun waxes and wanes, its influence weaves through the environment, interacting with land and atmosphere in complex ways. These patterns unfold over time, shaping the landscape in quiet yet powerful rhythms. With each cycle, the earth adjusts, readying itself for the gentle embrace of renewal that follows the flames, embracing the ever-present dance of nature in its elements. The peaceful, rhythmic flow of this natural interplay continues, inviting the world to rest and rejuvenate. Wood, a familiar presence in nature, holds intricacies within its fibers that dictate how it burns. With an energy density ranging from 15 to 20 million joules per kilogram, wood can release a substantial amount of energy when ignited. However, this energy is not consistent. The type of wood influences its burning characteristics. Hardwoods, like oak or maple, tend to have a denser structure, allowing them to burn more slowly and steadily, producing heat over longer periods. In contrast, softer woods, such as pine or spruce, ignite easily and typically burn hotter, but for a shorter duration. Moisture content also plays a crucial role. Freshly cut wood, laden with moisture, struggles to ignite fully, releasing energy less efficiently than seasoned wood, which has dried and condensed its resources. This interplay of moisture and density results in varying burn times and heat output, shaping the nature of any fire. Each piece of wood, with its unique composition, tells a story of potential energy waiting to be released. The fire reflects this intricate balance, inviting warmth and illuminating the tranquil night, as its flickering light dances softly in the darkness, continuing the harmonious journey of nature's cycles. Fire, a natural phenomenon, intertwines deeply with the rhythms of the earth. Over the course of centuries, fire patterns exhibit a delicate balance influenced by climate changes. When the climate warms, the conditions for fire can shift. Increased temperatures can create drier landscapes, where vegetation becomes more susceptible to ignite. This can lead to a rise in both the frequency and intensity of fires, significantly shaping the environment. As landscapes experience more fires, the cycle of growth and renewal unfolds. Some ecosystems rely on fire to clear old growth, making way for new life. The ashes nourish the soil, enriching it with nutrients. This interaction fosters a diverse array of plants and wildlife. Over time, areas can evolve dramatically as the fire season becomes more pronounced, allowing certain species to flourish while others adapt or recede. The gradual changes in fire patterns impart a lasting influence on the contours of the natural world, where landscapes transform, cycles renew, and life continues its enduring journey through time. Each flicker of flame reflects the ongoing story of our planet, a reminder of the interconnectivity of elemental forces shaping the Earth's tapestry. In the aftermath of a fire, a quiet transformation begins beneath the surface. The heat of the flames plays a significant role in this process, breaking down organic matter and releasing essential nutrients locked within. As plants burn, their remnants become ash, which contains valuable minerals such as potassium, phosphorus, and nitrogen. These elements are crucial for soil health, enhancing its ability to support new life. This newly enriched soil creates a nurturing environment for fresh growth. Seeds that have lain dormant are given a chance to sprout, often taking advantage of the increased sunlight and reduced competition for resources. Plants can emerge more vigorous and resilient, adapting to their surroundings in a way that reflects this new beginning. Over time, the cycle of life continues, and the landscape begins to flourish once more. The interplay of fire and growth weaves a rich tapestry where each cycle strengthens the soil, allowing ecosystems to adapt and thrive in a harmonious manner. This ongoing relationship showcases the resilience of nature as each renewal fosters the promise of new life. The land breathes, evolves, and prepares for the next turn in its timeless cycle. The dance of flames reveals a gentle spectrum of colors, each shade a reflection of the substances within the fire. When certain chemicals are introduced, they ignite the air with brilliant hues. Copper compounds, for instance, create soothing shades of green, sending ripples of color through the heat as they burn. In contrast, strontium brings forth deep reds, wrapping the fire in warmth and vibrancy. This interplay of elements showcases their unique interactions with flame, as energy is released in a colorful display. Each color forms not only a visual spectacle, but also signifies the specific chemical reactions taking place. The heat excites the electrons within the atoms, causing them to release energy in particular wavelengths, which our eyes perceive as color. As the fire flickers and shifts, the colors may change, flowing into one another like a soft melody of light. Such variations are reflections of the ever-active dance of molecules, where each color tells a story of its own. This quiet manifestation of chemistry unfolds in a realm filled with warmth and energy, inviting a sense of wonder as the fire continues to glow. The calm flow of colors in the flames remains an enchanting reminder of the elements at play, illuminating the night with their gentle brilliance. The flicker of flames not only creates a moment of beauty, but also connects deeply with the environment through the carbon cycle. When trees burn, they release carbon dioxide into the atmosphere, a process that unfolds gradually over years. This release occurs as wood, once part of a living tree, transforms under the heat of the fire. The combustion process breaks down the tree's complex structures, allowing stored carbon to escape. As this carbon dioxide enters the air, it mingles with the Earth's atmosphere, influencing the delicate balance of the carbon cycle. Gradually, the surrounding ecosystem begins to respond, with new growth emerging from the rich nutrients left behind in the soil. This cycle of regeneration often takes time, allowing nature to heal and adapt, while the released carbon influences the overall composition of the atmosphere. The slow dance between destruction and renewal illuminates the ongoing transformations in nature, where elements constantly shift and evolve. With each passing year, the land remembers the fires, embodying the rhythm of life and recovery, quietly whispering the stories of fire and growth as it moves gracefully through time. In the soft glow of a flame, tiny particles dance, weaving through the heat and light. These particles, known for their role in incandescence, play an important part in the gentle brightness that emanates from the fire. As the fire burns, these particles shift and change. Initially, they may be small, glowing softly as they heat up. With time, their size and composition can alter, influenced by the materials burning around them. This transformation creates variations in the light produced, leading to a flickering luminosity that ebbs and flows. When they are heated sufficiently, they radiate warmth and light, providing a sense of comfort in the darkness. As the flames continue their slow dance, the particles within adjust, affecting the overall brightness of the fire. This interplay provides a sense of continuity, where light becomes a living reflection of the fire's evolving nature. Each moment brings a new cast of flickering shadows, echoing the delicate balance of heat and energy at play. The fire glows softly, an ever-changing symphony of particles, quietly inviting us to rest in its warm embrace. Flames exist in a delicate balance with their surroundings, particularly influenced by the presence of oxygen. When oxygen levels dip below 16%, the very nature of combustion begins to change. In this lower oxygen environment, flames may flicker uncertainly, struggling to gather the support they need to sustain their glow. The dance of the fire becomes less vibrant as it lacks the oxygen required to fully ignite and sustain the chemical reactions that create heat and light. In these moments, the energy output of the fire wavers, making it unstable. This instability can lead to an unpredictable flickering as the flames search for a balance that might not quite be present. If oxygen drops too low, a flame may even extinguish, leaving behind only a faint memory of warmth. As fires burn in various environments, they adapt silently to these changing conditions, responding to the surrounding air. The gentle flicker of a flame in a well-ventilated space might appear more steady, vibrant, and alive, while in a more confined area with reduced oxygen, it takes on a quieter demeanor, a reminder of how intricately flames are linked to the air that cradles them. The glow continues, shifting, breathing quietly in harmony with its surroundings, ready to reveal the next gentle change. And the light from a gentle flame casts a soft glow, creating shadows that dance delicately across the ground. This gentle intensity of light affects the environment around it in subtle ways. Nearby plants, accustomed to the sunlight filtering through the leaves above, perceive this flickering illumination. The variations in light from a fire can influence their growth patterns as they stretch and lean towards the source of brightness. In the presence of fire, the surrounding flora responds to the changing light exposure, adjusting its posture in a quiet effort to maximize photosynthesis. Shadows momentarily shift as the flames move, creating a play of light that may encourage seedlings to reach upwards, while older plants might display a slower, steadier growth. Each flicker and pulse of light alters their surroundings, not aggressively, but rather softly nudging the plants to adapt to the environmental rhythm. These small interactions illustrate a calm yet profound relationship between fire and plant life, made up of tiny shifts in light intensity and shadow patterns. The interplay is a reflection of nature's ongoing dance, subtly guiding growth in delicate harmony. The light gently carries on, illuminating the night around, ready to unfold further intricacies of this quiet connection. The rhythm of nature often moves in cycles, and one of these cycles can be seen in the occurrence of forest fires. These events, though sometimes intense, are part of a broader pattern influenced by climate variability. During prolonged drought periods, the frequency of fires can increase, creating a complex interplay within forest ecosystems. Dry conditions lead to the accumulation of organic material, such as dead leaves and fallen branches. As these materials gather, they become fuel for potential fires. After decades of climate shifts that bring varied moisture levels, the landscape slowly transforms, responding to the cycles of rain and drought. Each cycle sets the stage for different growth patterns, encouraging certain species to thrive while others recede. When fire eventually ignites, its impact is not just destructive. It plays a role in rejuvenating ecosystems, allowing sunlight to reach the forest floor, fostering new growth and offering a fresh start. This connection between drought and fire is an ongoing exchange, one where each occurrence shapes the landscape over time. The forest, resilient and undeterred, continue their silent evolution, maintaining an intricate balance. The cycle is constant, quietly flowing into the next chapter of life within the woods, patiently waiting to unfold once more. In the gentle embrace of a contained fire, a delicate balance is achieved. When the flames are properly managed, they establish a steady temperature and size, creating a reliable source of warmth or heat. This controlled environment allows the combustion process to occur in a consistent manner. The careful arrangement of fuel, air, and heat transforms the fire into a stable element, one that can sustain its flicker for extended periods. As the fire operates in its regulated state, it becomes more efficient. Each piece of wood or fuel contributes to the continuous dance of combustion, converting energy with minimal waste. The heat produced radiates outward, enveloping the surrounding area and maintaining a gentle warmth. In this stable setting, the transformation of raw ingredients or the heating of an environment occurs at a steady pace, bringing comfort to its surroundings. This equilibrium allows for the rhythmic flow of energy, almost a heartbeat of nature, where the fire continuously renews itself, feeding off the fuel while offering warmth and light. It is a quiet, steady presence, a reminder of the natural world's ability to create balance in the simplest of ways, an ongoing cycle that flows seamlessly forward, inviting rest as it quietly persists. Fuel, composed of various substances, holds within it the potential for change. As fire encounters this material, a transformation begins. The chemical bonds that tie atoms together start to loosen and break apart. This breaking of bonds is not instantaneous. It unfolds gradually, allowing energy to be released in a steady manner. This release manifests as heat and light, guiding the flames as they flicker and dance. As energy is freed, new compounds take shape, and the nature of the fire shifts subtly. With each moment, the combustion process alters the characteristics of the fire, influencing its brightness and the size of its flames. As the fuel diminishes, the balance of heat and oxygen continues to guide the fire's behavior. Different materials yield different energies, contributing varied colors and intensities to the flames, creating mesmerizing displays of warmth. With each passing instance, the fire adapts and evolves, a quiet testament to the ongoing process of change. The gentle rhythm of this transformation invites a sense of calm, drawing everything forward into a serene flow, letting time meander softly onward. In a controlled environment, such as a fireplace, fire finds a steady rhythm. With a consistent supply of wood or similar fuel, it can burn gradually for hours. Each piece of wood provides its own energy, releasing heat as it succumbs to the flames. This combustion is a dance of molecules reacting slowly, giving the fire the capacity to maintain itself in a tranquil manner. As the wood ignites, the outer layers turn to ash, while the core continues to burn, transforming solid fuel into gases that swirl upwards. This continuous supply feeds the flames, allowing them to consume the material at a measured pace. The energy released creates warmth that spreads gently through the air, enveloping the surroundings in comfort. Gentle pops and crackles accompany this process, a soft reminder of the ongoing transformations within. With each passing moment, the fire adjusts, balancing its energy output with the nourishment it receives. This steady state can last as long as the fuel endures, the fire remaining a constant, soothing presence. The warmth invites a peaceful state, allowing thoughts to drift softly as the gentle flames continue their quiet work, inviting tranquility into the night. Heat produced by the flames generates convection currents, a gentle movement of air that arises from temperature differences. As the air near the fire warms, it becomes lighter and rises. This rising air creates a flow, drawing cooler air from the surrounding space toward the base of the fire. This cycle repeats, forming a soft, invisible current that helps distribute warmth uniformly throughout the flame. Within the heart of the fire, these convection currents lead to a balanced interaction among the wood, heat, and air. Hotter areas blend seamlessly with cooler sections, guiding the fire as it consumes fuel. The flames gently flicker and sway, responding to the shifting air surrounding them. This internal movement creates long-term patterns in the fire's behavior. Depending on the distribution of heat and available fuel, a fire can develop distinct shapes and rhythms. Flames may dance higher or settle lower as they adapt to the changing environment around them. This continuous equilibrium allows the fire to thrive, transforming matter into warmth that envelops the space. The soft glow remains steady, providing a comforting presence as the current quietly flows around, embracing the night. Thoughts soften like the gentle sway of leaves in a light breeze, calm and serene. The warmth of understanding lingers. Breathing becomes deeper, more peaceful, as the world outside quiets. Picture the gentle flicker of a single flame, cradled by the dark, dances softly, inviting relaxation, urging everything else to settle into stillness. The rhythm of the air slows, as if it too finds comfort in the quiet of the night. Each soft moment becomes a cushion of peace. The warmth of knowledge wraps around, comforting and tender, gently nudging thoughts away from the busyness of the day. Just as the flickering flame has its own rest, so too can each thought find a gentle place within, a tranquil haven. With a calm exhale, everything within begins to soften even more. The world fades just slightly, as if dipping into a comforting embrace. Each breath carries a lightness, a soothing drift, taking the listener to a place of ease and restfulness. Let the calmness wash over like a familiar blanket, soft and reassuring. It envelops the mind and spirit, leading to a soothing void where each heartbeat wraps softly around the stillness. It's time to embrace that serene quiet. Each moment draws deeper into peace, softly settling into rest. Good night from Sleepy Science Facts.